Nefeli, most people will know NVIDIA in the energy industry for subsurface modelling based on your HPC solutions. But you do a hell of a lot more. Modulus, NEMO, NIMS, what are you up to?
Yeah, it's a great question. We spend a lot of our time, as you said, on the HPC side. That is, the basis of our industry and where we really started as an energy team. But a lot of exciting work has come from that. So if we look at a traditional HPC workflow, simulation would be one of them, reservoir simulation or CCUS simulation, so where we inject CO2 and model, it's spreading the subsurface and ensuring that it's stored over, centuries. Those are usually very taxing solutions that are computationally heavy in general, especially when we're looking at CO2 injection and storage. So what we've been able to do is leverage a solution called Modulus, which is our physics AI solution, which includes a breadth of different models, including like FNOs and PINs and PINOs. But to spare you all the fun technical details, basically what it allows us to do is to leverage an AI solution that is trained on the physics, so on the equations, as opposed to on data.
Yep.
And so what that allows us to do is, one, ensure that we are honoring the physics of what the simulator would do, and we are not replacing any portion of the simulator. We are rather adding this to the numerical solution that allows us to accelerate the simulator. So then instead of taking, for example, 1 week to run, even if it's GPU accelerated, then we're looking at a few hours. And that is a significant, improvement also for decision making. And when we're looking at, projects that are time sensitive, and either you want to run more simulations to ensure that your results are ready and that they're accurate, different scenarios, it just allows you to accelerate that process.
Now, some of the folks may not be familiar. You've got NEMO, NIMS. What are these?
So, completely different portion of AI, equally as exciting, if not more so. With the Gen AI boom, since ChatGPT came out, NEMO is really our platform for Gen AI, and NIMS stands for NVIDIA Inference Microservice, and basically what it allows you to do, or the user to do, or whoever, is deploy and package these very quickly and allow your users, your customers, whoever, to run them. So it really is just a microservice that allows you to build, your Gen AI solution with different building blocks and makes it easier for you to ingest and deploy those solutions. And what's exciting about that is that we're seeing a huge uptick in Gen AI solutions in the energy space, right? Not unlike every other industry, not unlike, different sectors of industry, but especially in the subsurface, we're certainly seeing a lot of interest in leveraging generative AI to be able to help their engineers or geoscientists, geophysicists do the work that they would like to do, but give them the tools to make it faster for them by removing a lot of the busy work that is involved in all of those processes.
Now, here at GTC, large language models, foundational language models. Where are you headed with all this for subsurface?
For subsurface. In many different directions, of course. Foundation models are great because foundation models are trained on a specific subset of energy. So, for example, you would train a foundation model for like seismic, and then well logging, and then you can do it for reservoir engineering. But they are specific to subsets of subsurface. So it's not one size fits all solution. And what we're seeing is that what that allows you to do is when you train the model, there are different types of ways you can do it, but seismic, for example, you're training it on seismic images. You're not training it on text, you're not training it on numbers per se, you're training it on pictures, and you're trying to rebuild a 3D volume from that trained model. So that's what the foundation model is trying to do, and then from that, be able to do certain tasks that you're telling it to do. So we're seeing a lot of interest in that. And what the really value add there for any geophysicist, geoscientist, is that it really allows you to, say you want to identify the salt body within your seismic image, it'll do that for you. It'll give you the solution that you're looking for. So which is very cool. And there's the next step would be like a multimodal foundation model. So you're training it on, for example, images and text, and then you're training it to build synthetic seismic images that you can then compare to what you have internally to identify, what reservoir matches best with that. And then from there you can train it to do other things. So, we start somewhere, but they can get incredibly complex and more and more exciting as we build these out. So those are some examples of what we're doing on the foundation model side.
These are just some.
Just some.
Now, we were chatting earlier, obviously, a lot of what people were traditionally doing, it's reservoir modeling, oil and gas.
Yeah.
But cut a long story short, you mentioned about CO2 sequestration.
Yes.
Geothermal's getting a big push.
Big push.
Hydrogen.
Yes.
I'm assuming all of these start now, different models, different data, but this is all ahead of us.
Well, NVIDIA is a very interesting company because we don't actually provide any of these solutions, so we don't build products.
True.
We work with all of the companies that are interested in solving their hardest problems, and that's where we engage with them. And so what we're able to do is work with them on what they're most interested in. So CCUS being carbon capture, utilization, and storage, so think CO2 injection and storage, is of huge interest, especially with the energy transition. We're looking at how to model these types of projects effectively, reduce that computational time, reduce the actual time it takes to build and then run the model, because it could take months if you do it just numerically. So there's a lot of work being done there. Shell had published some work that they had done in the R&D space that highlighted this, and then they found a 10,000x acceleration leveraging Modulus to be able to do this. So think of that in your workflow. Months to days is a huge impact. Geothermal and hydrogen are exciting spaces as well. They're just not areas that we have worked on yet. Not because we're not interested, but we really need our ecosystem of partners, of customers to come to us and tell us this is our next challenge, this is what we would like to do, and so we would tackle it. And there's a breadth of technology available at NVIDIA, right? I just mentioned a few of the solutions that we use to be able to solve these problems, but there are certainly several more that we can use for all of our other energy needs.
We could have a Netflix series just on this. Last question.
All right.
GTC is just kicking off.
GTC.
Any particular highlights that you're looking forward to hearing?
Yes, of course in the energy space I am thrilled about a lot more of the intersection of different types of energy and different AI solutions for energy and how they come together. So we work in the power and utility space, and you'll hear from my colleague later on about that. We work in the mid and downstream space as well. There's a lot of exciting work, but between the power and utility space and the subsurface companies that we work with, we're seeing a lot of synergy of how do you leverage some of the tools and platforms that exist to be able to be used in the power utility space, which is maybe a bit newer to NVIDIA, to accelerated computing, to AI solutions. So I'm excited to hear all about those. And of course, I'm excited for all the robots that we're going to see on the show floor.
Me too. The whole physical AI fascinates me.
It's very exciting.
And I'm sure physical AI will have a role in the energy industry as well, right?
100%. If you think of all of our offshore operations, remote operations, we can make those types of works, that type of work easier for those that are working in the field.
Humans from dangerous places.
Why not help them with robots?
As I say, we could be here all week. We will be here all week.
Yes.
But Mary, thank you so much. Hey, I wish you well.
Appreciate it. Thank you very much.